we've got the wheelchair swing. Take notes, ask questions. Thanks very much, guys.
Hi. We are the last presentation for Dr. Newman Carr's group, and we have the wheelchair swing, and I'm Abby Borka. And presenting with us is Christy Stellingson, Nate Wilson, Chase Rovers, and Wayne Rotanka. And our client was Dana Dold from Latham Elementary, and she came to us with a problem that they only have one handicap swing. Well, they wanted it to be easier for them to wheel a child up, I guess, to a swing, because it was a hassle for the teachers and such. And another problem was that the chair wasn't adjustable, and it's set in pea gravel, so it's kind of hard to wheel them up there. And so what we had to fix was its adjustability, its lack of trunk support, and the pea gravel, which to fix it, the things we had to tackle were to strap in kids who were at least 30 to 50 pounds in weight, and we had to have whatever swing we chose to be durable and lightweight and last a long time through the seasons and all that. And so we came up with some materials for brainstorming. Some of them we rolled out because, well, they wouldn't last well in the conditions of Wisconsin, and some just weren't really practical. But these are all the materials we came up with when we had the idea of using a platform or a chair like they had. And we came up with these to use. We didn't use all of them, but these were things we kind of had an idea for to use.
All right, these are some of the possibilities I have for our swing. These are the first two that we came up with. Obviously, we ended up going with this one, more practical design. There are a couple factors, one being the ease of this, easy fabrication. So we ended up going with this one. This is another version of the swing. And then this is obviously the real deal. This is what we ended up having. We have a grab in front. There's a under bar to help with the support on the bottom. And then on the side here you have another the rack or the pipe hangers to actually connect it to the frame of the swing. This is just another video. Obviously, SolidWorks was a huge help for us. And, well, essentially, it just would go in a 360 motion, and it would kind of show around it. Oh, here we go. And obviously, you can see those are the pipe hangers.
Okay, and with our final design, we came up with a big list of actual materials that we use. The main material for the swing is just steel. One, because it was durable, while steel is heavy, the application we had for it kept it relatively light. And also we could weld it, which helped become durable also. We used stainless steel on the hinges for both the hangers and the ramp, because at that point they would be the weakest, so we wanted that to be the most durable. Also, we used 3-pound expanded metal grating. That is this grating you can see here, and is designed for both the platform and the ramp. Because one, a solid sheet of metal would be extremely heavy, and two, unnecessary, because you just don't need that large or that heavy of an item to hold a child. this is shown here because it's kind of external, is an eye anchor, which is basically a corkscrew that screws into the ground. And at that point, there's a chain that comes from it. It's about 3 feet long. It goes to the ground. And it comes up and it hooks to the bottom so that when the swing is not in use, it doesn't move. And that would be locked so that only people who are authorized to use it would be able to actually use the swing. That includes the chain. And then also there are these ratchet tie downs, which are just your basic ratchet system, like for an ATV trailer or things. And they have, as you can see, like J hooks on the end, so, and all wheelchairs have a hook, hooking system to be able to hook down in public transportation areas. And then finally, to lock the ramp up, and as well as the aisle, we have padlocks. Some obstacles that we had to overcome when making the swing, because as you can see, it's kind of a large project, was first of all, most importantly, time. Only having 14 weeks with a holiday in there really kind of put a clamp on how much time we had to work on something so large, especially when designing and brainstorming came up in such a large chunk of time because there's so many variabilities with what we could have done with this swing. Another thing is budget, considering we had a fairly small, or not fairly small, I should say. We had a budget, and working with such a large scale project within those conditions was kind of challenging. And finally, because this is such a specialized kind of project, parts that would be compatible for working with both wheelchairs and like our materials to be durable outdoors were hard to find. And then we also had wrong parts arriving, which became a big deal because twice we'd order pipe hangers that we'd need to use in order to hang this from the existing swing set, and they were delivered. They delivered the wrong product simply because they didn't have one and thought that the other one worked just as well, but that's not the case. And finally, because we were dealing with a person who was very generous in volunteering their time, he not only had his time constraints because he also has life, but we only had one or a few people that could weld at any one time. So putting in just a certain amount of time was really, like the amount of time we work at it once was kind of a constraint also.
Alright, the fabrication process, as seen in some of the pictures above, required a lot of dedication and effort throughout the lab time and out of class as well. As seen, it involved a lot of cutting, welding, and measuring, all of that galore. And all this would not be possible without the help of Chet Hermanson, who's here today. Thank you, Chet. He allowed us to basically come into his shop and use all of his tools and grab some of the knowledge that he was so thankful to share with us. So we started the process by squaring and measuring, cutting the skeleton for the platform of the actual swing, which is this rectangular base made out of angled iron or steel. And then we had to make the platform of the ramp as well. And so we squared that all off, made sure our measurements were precise, and we had to weld it all together. Also, we put a piece of steel in the middle of the platform and the ramp to reinforce strength. So we had to weld that on as well. From there, we had to place the expanded steel in here. We had to cut it, shave it down so it wasn't super sharp to all the edges, which required grinding and more welding. From there, we welded the expanded steel into the skeletons of the platform and the ramp. Then, from there, we had to make the A-frames. So, again, measuring, cutting, welding. Then, in our final, here's an example of our welding in action. And also, we had to take the classes through the shop, the engineering shop here, in order to get certified. And Chet also supervised us and helped us along the way to make sure our molds were trustworthy. From there, we had to weld on the hinges. There's 3 hinges that attach the ramp and the platform together. We had to put on the 3 sidebars, just in case somebody needed to grab onto it if they weren't weren't feeling safe, and it's also to help the teacher guide while swinging. And right here, even though it's a bit difficult to see, there's a picture up in the top right corner. We have two O-rings that overlap so that the ramp can lock to the main frame. So this is for safety when the swing isn't being used, and also when the child is in the swing itself, it's intended to be locked as well so that the ramp just doesn't go flying down. And the last step was attaching the swing hangers, which involved curving a metal rod and then welding it. Inside of it, there's a little loop attached to the bottom of the swing hanger. So we put the rod through the loop and welded it to the tops of these two rods. And now everything is complete.
Okay, after doing some SolidWorks testing, we were still questioning the possibility that the existing swing frame could topple, break, or bend in some way. So we went to the on-site location, which is Lafayette Elementary, not far from here, and we conducted some experiments. This is how we tested on site. We suspended a total of about 450 pounds from the top bar of the swing set, and we concluded that the deflection of the top bar was immeasurable. It did not break, obviously, it did not topple, and it did not bend.
Well, we spent a lot of money. We went over budget a little bit, but it's kind of hard making something this big under $300. And I guess if we didn't really have to pay for labor, it would have been a little cheaper. But we went through the materials, you saw what was what, and I'd like to say thank you to a few people. Our instructor, Amit Nimankar, our SA, Hope Marshall, our driver, Zach Hertzberg, Chet Hermanson for letting us use his shop throughout the whole semester, Mark Mortensen, who actually let us powder coat for free, and John Finmore, who advised us through a lot of things and legality issues. And are there any questions or comments?
I was just a quick one to clarify. So most